Today we're starting Unit 2, which is about rational and irrational numbers. You may have heard the word irrational before, which means something doesn't make sense, and that's kind of how irrational numbers work in math, but it's a little bit more specific. So the opposite of that, a rational number, rational numbers are any numbers that can be written as a fraction. So whole numbers can be written as a fraction. So if you had the number 2, we could put it 2 over 1. Most decimals can be written as a fraction. But the problem there is that, like we talked a little bit about in Unit 1, 0 can never be in the denominator. You are not allowed to divide by 0 in math. So it couldn't be any number over 0, or it couldn't be any number divided by 0. You are not allowed to do those things in math. You can do 0 divided by a number, so it is okay to turn them around the other way. So you can do 0 divided by something. That one's all right. But you cannot do a number divided by 0. Some other characteristics of rational numbers is if they turn into a decimal, they might be repeating or they might be terminating. Repeating decimals, they have a line over the repeating parts. So you might remember this, like if you had 0.3 repeating, which is 1/3, that you would just write that. Actually, let me rewrite it. You would just write that as 0.3, just with the bar over the 3. And then terminating decimals are decimals that will end. If you are using your calculator, and we will be using calculators for the first time, if you're using a calculator, your calculator can only do so many decimal places, but you can pretty much tell if it's not going to repeat because it's going to be just a bunch of crazy numbers. We'll talk about that in a little bit. One example of a rational number is anything that is a perfect square, which relates to square roots. So perfect squares are rationals. These are numbers that are on the diagonal numbers on the multiplication chart. So what we mean by that is on your multiplication chart and on yours, some of them, it didn't show up very well, so we may have to get out some highlighters and highlight them for you. But the numbers that are perfect squares are the ones that are whole numbers, a whole number multiplied by itself to get that number. So 4 is a perfect square. 36 is a perfect square because it's 6 times 6. So any number that's under the square root symbol that's not in that diagonal would be irrational. Also, the numerator and denominator of the fraction both have to be rational numbers themselves. So you can have a non-repeating decimal or a decimal with a repeating pattern in the numerator or denominator of a fraction, or you could have a fraction in a fraction, which we'll talk more about later also. Now let's talk about the opposite of that. So irrational numbers are the opposite of what we just said. An irrational number is any number that cannot be written as a fraction. Non-perfect squares, so those are ones not on the diagonal, and decimals that never end and never repeat are irrational. Some irrational numbers that we're going to use this year include pi. So that little symbol is actually a Greek letter, and it stands for pi, which is not 3.14, but we round it to 3.14. So pi actually has to do with circles, and that pi decimal continues on forever, and it doesn't ever repeat, and it doesn't have any patterns. Also, you cannot have a negative inside your square root symbol. So you'll see a negatives outside the square root symbol when we're putting them in order, but you cannot have them inside. So now let's practice a little bit with that. You need to identify which numbers are rational and which numbers are irrational. So we're just classifying right now. So that symbol's pi we just talked about. pi would not be 3.14. That's what it's rounded to. Pi continues on forever, so pi is irrational. And then 1/3, the definition is it can be written as a fraction, and 1/3 is definitely a fraction. So that one's rational. Now the square root of 29, I can check back on my number line here, and I can look, and I'm looking at the diagonals, and I'm looking for 29, and I see a 25 and I see a 36, because 5 times 5 is 25, 6 times 6 is 36. So 29 is not a perfect square. So anything is not a perfect square will be irrational. And then the last one we're going to do together is the square root of 49, and then you're going to practice the other ones on your Edpuzzle. So the square root of 49, I go back to my multiplication table and I look at, there's 49. So the square root of 49 is 7, because 7 times 7 is 49. So that would be a rational number. Now try the next 4 and check them with the video, check them with the Edpuzzle video. And the last thing before we practice, we're going to talk about how to compare rational and irrational numbers. This time we're just talking about if it's less than or greater than. Remember, alligator eats the bigger number, or if they're equal to. So for part A, we're looking at the square root of 16 and 24 out of 5. So the square root of 16, if I go back to my multiplication chart, I can find 16, and I see that 16, the square root of 16 is 4, because 4 times 4 is 16. So that one equals 4. And then we have 24 divided by 5, which is a lot easier to compare as a decimal. We will be turning a lot of our fractions into decimals. 5 does not go into 2. 5 goes into 24 4 times. 4 times 5 is 20. Subtract and I get 4, and then I have to put a decimal and a 0. And 5 goes into 48. So 24/5 is the same thing as 4.8. And they weren't easy to compare at first, but when I turned them both into a whole number and a decimal, I can see that 4.8 is greater than 4. Now we're going to try one more, and then you are going to do C and D and practice and check on your Edpuzzle video. So part B, I have 9.5. You don't have to worry about that. It's already a decimal. But now I need to figure out what the square root of 64 is. So I go back to my multiplication table. I look for 64, and I see that 8 times 8 is 64. So the square root of 64 is going to be 8. And now I can tell that 9.5 is going to be greater than 8. So now try C and D, check it with your Edpuzzle video, and then you're ready to practice.